Hello everybody, it's Miss Manelia again, and welcome to the third and final installment of your midterm review. In this third tutorial, I'm going to focus on Unit 4, which covers sequences and exponential and logarithmic functions. I'm going to start with sequences, which is actually toward the end of your review packet because we covered that first. And problems number 16 and 17 are both calculator based. So let's take a look at number 16. We're looking at enrollment at a local community college had plateaued, which means leveled off, until the school began offering online classes a few years ago. The table below gives the total enrollment at the school for the years following the introduction of the online courses. So in the first year they had 2,000 students, in the second year they had 3,000, and then so forth and so on. If we look at part A, we're asked to write an explicit formula. So this has to do with sequences and looking at how those numbers of students is changing from one year to the next. So I can kind of tell just by looking at it that it's not going to be arithmetic, because if I consider the difference between 2,000 and 3,000 students, that's an even thousand. So if it was arithmetic, then I would expect the next number to be 4,000 and then 5,000 and so forth. So it's pretty obvious, I think, that it's not going to be arithmetic. So the only other sequence we talked about was geometric. So if it's geometric, then it should have a common ratio. And to find the common ratio, we always want to start with the second term and divide the first. All right, so if I do this on my calculator, I've got 3,000, and this is a calculator-based question, divided by, sorry, my calculator has been a little finicky. I get 1.5. And so the one thing you do probably want to do is test that to make sure that it works. You could go ahead and just write your explicit formula. So based on the information in the table, write the explicit formula. Well, let's make sure we remember. If it's geometric, it's going to have that common ratio. And my formula is going to look like a sub n is equal to my first term, which we're just going to call in general a sub 1. And with geometric, since I'm constantly multiplying by the same thing over and over again, I'm going to multiply by r. And when I'm multiplying the same thing by itself over and over and over again, that changes the exponent. So I'm going to raise r to the n minus 1 power. And so if I think about my situation, the first term in this sequence is 2,000. And so my equation should start off as 2,000 times 1.5 raised to the n minus 1. If you want to write this as a function, you certainly can. In that case, we'd use notation like f of x, and then we'd say f of x is equal to 2,000 times 1.5, and then instead of using n, I would raise it to the x minus 1 power. It really doesn't matter. But if I want to double check to make sure that that formula is correct, I'm going to want to go into y equals and type it in. So I'm going to clear out the two equations that are in there now and go ahead and enter my formula. So 2,000 times 1.5, and I'm going to raise that to the x minus 1. And with the newer calculators, because you can see that the exponent is clearly raised, you don't actually need parentheses, but I think it's a good habit to get into, especially if you have an older model, to keep parentheses around your exponent. And so what I want to do now, I don't know why this isn't, there we go. All right, what I want to do now is to double check to make sure my table is correct. So if I go into second table, or second graph, and I scroll back until I see when x equals 1, I can compare the numbers in my calculator's table to the numbers on the worksheet to make sure that they're the same. And they are, so I know I have the correct formula. The next question is saying to use our model to estimate the number of students enrolled in the community college in year 8. Well, now that I have this on my calculator, I can very easily just scroll down to year 8 and know that it's going to be 34,172, or I can simply let n equal 8 and plug it into my formula. So I'd have 2,000 times 1.5 to the 8 minus 1. And I prefer to see the work. If you're one of my students, I'd rather see you write it out, but you can solve the problem either way. So if I plug this in, and then I'm raising it, and then in parentheses, I mean, you can just type in 7. Obviously, you guys know that 8 minus 1 is 7, but just go ahead and type it in that way. And again, you can see that the answer is going to be 34,171. Now on the table, let me go back for a second. Notice that this gives us a decimal value. This would be students, so let me go ahead. Make sure that if you're asked a question in context, that you answer it in context as well. If I go back to my table, you'll notice that when x equals 8, the y value is 34,172. You can see that it's actually rounded, and that's only because only 6, or I guess 5 digits will fit into that column. If you scoot your cursor over so that the number's actually highlighted and look at the bottom of the screen, you'll see that it actually produces the exact value, which is 34,171.875. Now, when you're answering this question, obviously, we're not going to expect 0.875 people to enroll. I would prefer my students to write the exact value, and then in a sentence, if you wanted to say there would be approximately 34,172 students that year, that would be an appropriate way to answer it. But I particularly like to see the exact number to know that you're doing it, that you're doing the math correctly. All right, in part B, now we're moving on from just looking at the explicit formula and a certain term in the sequence to trying to find a total. So part B says in the first bullet, this year is the 10th year the college has offered online courses. Assuming that the pattern from the chart continues, determine the total number of students who have enrolled in the college since the online classes began. So we know in the first year there were 2,000. In the second year, there were 3,000 new students. So that means now by the second year, a total of 5,000 students have been enrolled. And so if we want to find the total, I'm now going to have to use my sum formula for a geometric sequence. And the sum formula for a geometric sequence for the first n terms is always starting with my first term, and then we do 1 minus our ratio, and we raise it to the n, which is the number of terms I'm trying to add together, and then I divide that by 1 minus r. And so in this case, I'm trying to find the sum of the first 10 years, or the first 10 terms. So again, I'm going to look for my first term, A1, which I know is 2,000. And then I'm going to multiply that by 1 minus my ratio, which I calculated to be 1.5. Since I'm trying to find the sum of the first 10 years, I'm going to raise that to the 10th power. And notice that I raise it to the 10th power before I close my parentheses. It's the ratio that's being raised to the 10th, not the parentheses. And then I'm going to divide that by 1 minus 1.5. Okay, so I'm going to go ahead and type that in. So I'm going to have 2,000 times 1.5. Oops, I'm sorry, I'm doing the wrong formula. I'm sorry, 1 minus 1.5. Raise that to the 10th power. Make sure you pull the cursor out of the exponent and close your parentheses. And then I want to divide by, and again, make sure your denominator is in parentheses, 1 minus 1.5. Okay. And that will give me my total, which is, looks like 226,660.156 students. And again, I prefer seeing the exact value, and then if you want, like in a sentence to say approximately 226,660 students were served, if you want to round. Ask your teacher what they prefer, just so since they're the ones that are scoring it, just ask what they expect in terms of the rounding. The last question is actually just on the honors exam, but I'll go over it for everyone. So this is a selected response. It says the dean of the college wants to plan a special ceremony for alumni when the total enrollment reaches 500,000 students. So again, we're talking about the sum. And during which year will the total enrollment reach 500,000? And so your answer choices begin with year 10. Well, I've already found the total for year 10. I found the total at year 10 to be 226,660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 660, 6 So if I want to figure out the sum of the first 11 years, I think with this problem, there's probably other ways that you can do it, but I think in this case, since it's multiple choice, it might be easier just to do trial and error. Since I already have the command in my calculator for 10 years, if you hit second enter, it'll just populate that command again, and then all you need to do is use your cursor to go back to that 10 and change it to 11. And now I can find the sum of the first 11 years. And I'm just going to write that number down. Now we're at 341,990. And I'm not going to worry about the decimal places because I'm just going to be choosing one of these. So at the 11th year, it's not quite 500,000. So let's do the 12 years. I'm going to go ahead and hit second enter. And I'm going to scoop back until that 11 is highlighted, and I'm going to change that to a 12. And so now I can see that by the 12th year, notice by the 12th year, we've actually surpassed the 500,000 mark. So we're at 500, whoops, I wrote that wrong. We're at 514, oh shoot, 514,985. Let me rewrite what I had. This was 341,990. Okay, so I know I don't need to go any further because by the 12th year, there's been 500,000 students, or 500,000. But let's make sure we answer the question correctly. During which year will the total reach 500,000? So when you think about, when I plugged in 11, I was plugging in the number 11.0, and I got the 341,000. When I plugged in 12, that's the number 12.0. And so I got 514,000, which is a little bit high. So it was somewhere between 11 and 12 that my enrollment actually hit 500,000. So the correct answer for this problem is going to be 11 years, because it's somewhere during that 11th year that the enrollment hits 500. So it's going to be during the 11th year. Sorry, I kind of wrote over that and made that hard to see. So even though 11 years is a bit low, it's during the 11th year that the total is going to reach 500,000. And again, that's on the honors exam only. All right, number 17 is also another calculator-based question. And again, we're looking at a sequence of numbers, and we have to pick the correct explicit function. So I can tell, I mean, if you look at your possible options, they all represent a geometric sequence or an exponential function, whichever way you want to look at it. So I know that this is not going to be arithmetic. I don't have to look for a common difference. What I need to do is look for the common ratio again. And just like we did in the last problem, I'm going to take my second number and divide it by my first. And 900 divided by 1,500 gives me a common ratio of 0.6. Well, if I look at my bases here, if I look at my common ratio, none of them look like 0.6. So I can change it to a fraction by hitting the math button, and the first option will change it back to a fraction for me, and so I get 3/5. So that immediately eliminates D and A. So my only other options are B and C, and since both of the exponents are x minus 1, I need to identify the first term. And since it's 1,500, I know that the correct answer would be C. Okay. You know, another way of doing this problem, while we're here, another way of doing this problem, if you completely forget, would simply be to plug the formulas into y equals and then compare. You know, this would have to be your initial term, and then compare the sequences to the table values. And that would be another way if you completely forget what to do, because this is a calculator-based question. Okay, The next couple of questions deal with strictly exponential, and I think in this one it actually talks about a log too, but it's talking about the graphs of the two functions and equations of the asymptotes. This is a non-calculator question, so you are expected to understand the nature of the graphs. Remember, with an exponential function, let me just sketch a picture, we either have exponential growth or exponential decay, which looks like this. All exponential functions are going to have a horizontal asymptote. So if it's exponential, you will have a horizontal asymptote. Okay, all horizontal lines are going to be of the form y equals, which is, I don't know, kind of illogical, because when you think about horizontal, you think from left to right, and that makes you think of the x value. But a horizontal line means that all the y values are the same. It doesn't matter what x is. The y values are going to be the same. If your function has been transformed, then you want to think about the value that affects the values on the y-axis. And that's going to be your k value. So whatever your k value is going to be your horizontal asymptote for an exponential function. So in this problem, it's going to be y equals 3, and it's going to be a horizontal asymptote. A logarithmic function, you will learn, is just the inverse of an exponential. And so when we think about an inverse graphically, we're actually reflecting it over the line y equals x. So a logarithmic function is going to have a vertical asymptote. And so our logarithmic graphs can increase and decrease as well. But this time, they have a vertical asymptote. So if it's a log function, it will have a vertical asymptote. And if you think about it, a vertical line is not a function. And so it's not something that I can enter into y equals. And if that helps you to remember that all vertical lines are of the form x equals. And so if you think about the transformations of our graph and what affects the x values, it's going to be the h value, or whatever is inside the parentheses with x. And so the vertical asymptote for a logarithmic function is always going to correspond to x equals the h value. And what you also have to remember within the parentheses is that it's always going to be opposite the number you see. So if I take a look at g of x, if it's a logarithmic function, I know it's going to be x equals. And even though I see x minus 1, I need to remember that my h value is a positive 1. And again, this is going to be a vertical asymptote. Okay. Number 15 is a problem you can use your calculator on. This is an exponential situation. The population in thousands, which we're going to represent with the variable y, of a small town can be represented by the function y equals 48.2 times 0.97 to the t power, where t represents the number of years since 1980. So when I'm using dates like this, I'm using 1980 as my reference year. If t represents the number of years since 1980, it means that 1980 corresponds to when t is 0. So when I'm thinking about my years, I'm not going to be entering in 1981 or 1982. I would be entering in t equals 1 or t equals 2. So if I'm given the equation, it's very similar to the formula that we had for a geometric sequence. What was the population of the town in 1980? That's going to be my initial value, that 48.2. But be very careful of the units here. I know that the population in the town wasn't 48.2 people. The population in the town is in thousands, so I'd also want to make sure that I include the word thousand. So there were 48.2 thousand people in the town in 1980. Is the population increasing or decreasing? Well, this is where you look at your ratio, or your base. That base is 0.97. What that means is every year the population is 97% what it used to be. So does that mean it's getting bigger or getting smaller? If I take 97% of something, I'm not taking all of it. That means that the quantity is decreasing. By what rate is it decreasing? If 97% of the population is left, that means it's decreasing by a rate of 3%. So the way you calculate the percentage rate, you always want to find the difference between the value in the parentheses and 1, and it should be positive. So for example, I would just say that my rate is equal to 1 minus 0.97, and that's going to leave me with a 0.03. Well, 0.03, when I change it to a percent, is going to be 3%. Because if I multiply by 100, I'm going to be moving my decimal place 2 places. The last bullet says, what was the population of the town in the year 2000? Again, I don't want to enter 2000 into my calculator because I started at 1980, and 2000 is simply 20 years later. So I'm going to let t equal 20, and I'm going to go ahead and enter my equation into my calculator. So 48.2 times 0.97 to the 20th power. And I get, so let me write this out, 48.2 times 0.97 to the 20th power, and that leaves me with 26.21. I'm going to go ahead and do 3 decimal places. And again, I want to remember that I'm talking about thousands of people. Okay. Now we're moving on to logarithms. We're almost done. And the first couple of problems that deal with logarithms are non-calculator based. They both deal with properties of logarithms, which also include properties of exponents as well. So in number 1, we're looking at the expression where we have the log base 5 of 3x over x to the 5th, and we're asked all the different ways that we can re-express it. So one of the first things I notice, let me rewrite it so it's a little bit bigger. We have 3x over x to the 5th. One of the things I notice is that I have something in common here. So I can reduce that fraction. If I've got an x on top and 5 factors of x on the bottom, I can cancel one of those factors. So this would be equivalent to the log base 5 of 3 over x to the 4th. Because if I think about it, if I rewrite this, this is 3x, and x to the 5th is just x times x times x times x times x. And I can cancel one of those x's. And so that leaves me with the log base 5 of 3 over x to the 4th. Our properties of logs basically say when I multiply, I can separate the logs and add them together. And when I'm dividing, I can subtract. So one way to re-express this first quantity would be to say that this is the same thing as the log of 3. Let me go ahead and include my base 5. Since I'm multiplying by this x, I could add then the log of x, or the log base 5 of x, and then I'm subtracting the x to the 5th, or the denominator. So I'd have minus the log base 5 of x to the 5th. Now I can't leave this exponent here, so we also have a property that says that I can bring it out in front. And so if I look at my options, I think letter B corresponds to what I have written right here, because letter B has the log of 3 plus the log of x minus 5 times the log of x. So B is correct. Oh, and I forgot. When I re-expressed the equation this way, the log base 5 of 3 over x to the 4th is simply what we saw in letter A, so I forgot to check that off. All right. If I take a look at letter C, I can tell that that's not correct because I'm not subtracting this log of x. So I know letter C is not correct. And letter D, I think, is just what I would get is if I re-expressed the simplified version, because I would simply have the log base 5 of 3 minus the log base 5 of x to the 4th. But again, I could bring that 4 out in front. And so that would correspond to letter D. So A, B, and D are correct. And this was a simpler version. Number 2 kicks it up a notch. And this is going to be more like what you would expect to see on the honors exam. Let me rewrite it again so it's a little bit bigger. So we have the log base 5. And we have 6ab to the 4th over a squared b squared. So the first thing I might want to do is sort of rewrite it as a simplified expression. So I'd have the log base 5. There's nothing I can do to simplify the 6, so I'm going to keep the 6 on top. But if I think about my a's, I've got one factor of a on top, and I've got two factors of a on the bottom. That means I can cancel one of them, because on the top I have an a, on the bottom I have a times a. So I can cancel one of them, and that leaves me with an a on the bottom. If I think about my b's, I've got 4 factors of b on top and 2 factors of b on the bottom. That means I can cancel 2 factors of b, and I'm left with 2 factors of b on the top. So that leaves me with b squared on the top. And so the second quantity would correspond to a simplified version. All right, so I can tell right away that letter choice A is not correct because I shouldn't have an a squared on the bottom. So I know that's wrong. So I'm going to go ahead and cross that off. So now let's think about what my log rules should look like. If I simplify, or if I rewrite this first quantity, I'm going to have the log base 5 of 6. I'd want to add the log base 5 of a. And then I'd also want to add the log base 5 of b to the 4th. And remember, I can take that 4 and put it out in front. And then the quantities on the bottom, I'd want to subtract. So I'd have minus log base 5 of a squared. I'd also, because the b squared's on the bottom, I'd also need to subtract the log base 5 of b squared. And both of those exponents would come in front. And so now I want to look to see if that's any of my answer choices. And it looks like that corresponds to letter E. So I have the log base 5 of 6, the log base 5 of A, plus 4 times the log base 5 of B, and then I'm subtracting 2 times the log of A and 2 times the log of B. So one of the correct answers is going to be E. If I simplify this expression here, I'm going to have, let me do this, I'm just going to do this up at the top. I'm going to have the log base 5 of 6 plus the log base 5 of b squared, and then I'd need to subtract the log base 5 of a. And I know that this exponent here can come out in front. So I'm going to want to see if that corresponds to any of my answer choices, and it does not. So it doesn't look like any of the other answer choices are going to work. I think the correct answer here is simply E. It's the only correct answer. So even though that this is a multiple response problem, there is only one correct answer. Okay. Number 13 is a calculator-based question, and it is a straight-up calculator question. You're asked to evaluate the log. So if you have one of the new calculators, it's actually very simple to do this. You'll notice you have 2 log buttons on your calculator. One is LOG. That is the log. So when you see log, that is the log base 10. The other one is the natural log, and that corresponds to the log base E. So if you have the log base 6, you need another way to enter that into the calculator. The older calculators require you to use the change of base formula, but if you have one of the newer ones, if you go into the math menu and scroll down, you have to scroll down pretty far, I think. Okay, I think it's option A, says log and then base. So if you choose this option, it'll actually give you the log expression with the base in it. And so you can just type in the 6 in that little subscript, and then you can type in your argument, the 23, in there. And you end up with 1.74995. That's going to actually round up to 1.75. If you don't have one of the newer calculators, it's no big deal. We have a formula that says if I have the log base, let me call this base B. Sorry, let me make that a little bit neater. If I have the log with base B and I'm trying to find the log of A, I can rewrite this and think about like kind of drawing like an imaginary line here. this is the same as taking the common log of a and dividing it by the log of your base. And so I'll use the change of base formula for the second one. If I want to evaluate the log base 4 of 124, that's going to be the same as taking the log of 124 and dividing it by the log of 4. Now you do want to make sure that you have parentheses around your arguments. And so if I do it this way, I would take the log of 124. I'm going to close the parentheses and divide by the log of 4 and close my parentheses again. And when I do that, I get 3.477. And just to show you that you get the same answer, I can go ahead back to that math menu. And if I scroll down to option A, I can also go ahead and type in the 4 here and the 124 as my argument. And when I press enter, notice you get the exact same answer. So either way is fine. All right, and that's it. Imagine that. All right, so I really hope that this was helpful. Obviously, if you have questions about any of these problems, come in and talk to your teachers. Good luck on your exams, guys. I hope that this was helpful.